Welcome to our VPN lab today. We're going to go through a VPN tunneling lab that we're going to do through Packet Tracer. And in this lab, we're going to simulate a tunneling um, infrastructure. So we'll have computers on one side being able to create a tunnel or build a tunnel, encrypt traffic through two routers, which we're simulating to be the internet. And that traffic can go across the routers, encrypted, so that if anyone was to try and grab the traffic there, the packets, they would not be able to. So we're going to use Packet Tracer for this activity, which is a really awesome tool. You can practice Cisco technology and you can practice normal networking tools as well. Really good learning tools. And let's go into this. So I'm going to quickly build the infrastructure for this. So we're going to need a couple of routers and another one over here. I might just make that a bit bigger for us. Okay, that's a bit better. Awesome. And I'll go and put my head out of the way there. And I can, any router should be okay. So any switch should be fine. Shouldn't make too much of a difference. Excellent. And now what I would like to do is I could automatically choose the connections here, but I like to get in the habit of making this real world kind of stuff. So between a router and a switch, we will use a straight through usually for this, and I believe that is a fast Ethernet from that section to that one. We can double check the straight through cable from R1. So this is we're going to call this R1 by the way, R1. And that's going to use fast Ethernet. If we point the mouse over, you can over the red triangles, it tells you the actual name of the interface. And yeah, so that's so far so good. From a router to a router, we're going to use a crossover cable. So from fast Ethernet 1, connecting over to 01 on this side as well. Excellent. It in the real world with AutoSense, you don't have to worry about the straight through and crossover cables. It's not a big issue, but I still like to get in the habit of that. From my personal experience, I've been burnt by using the wrong cables. So just out of just remembering to do it the right cables, I never, hopefully I never run into those kind of issues again. Now we're going to grab a couple of PCs down here. It can be a laptop PC, doesn't really matter. They're the same. And I'll get another one over here, and then I'll connect that with the straight through cable. Straight through means is a cable that's from one device to another that are not on the same layer on the OSI model. So computers are on layer 3. They're on the same layer as routers. Switches are on layer 2. So I can use straight through between the different layers. Let's jump over to this guy over here. And it doesn't matter which way you connect on the switch there. Let's make it a bit tidier. And that's looking okay. Now we get into the fun part. Now we're going to start configuring. I have already got the configuration already copied, and I'm going to go into router 1 and jump into the command line interface. Just going to type no for this. And so I've already copied the commands, and basically I'm going to just paste that in there, and that's going to do the configuration for me automatically. All I'm doing with this at the moment, I'm just giving it IP addresses and to the interfaces. Because this is not a Cisco lesson on the commands on the Cisco, we just want to check the tunnel out. I'm not going to go through these commands. But there might be another video presentation on actually how to configure routing commands on Cisco routers. But you'll notice that there's green everywhere. So they're working. We've established um, communication there. We'll go over to the next router, which we will call router 2. Go into here, command line interface. We'll type in no, enter a couple of times. And I've got the commands already written down here. I just want a quick setup for this. Excellent. And you can see green everywhere. We like green. Excellent. So I'm just going to make sure that I can ping that router over there to make sure I've got connectivity. I know the address is, let's go to PC. I know the address is 192.168.1.1. Let's do it. Let's ping that. Doesn't seem to be working, so I'll have to do some quick troubleshooting live. Let's go back over here. I'm just going to do some quick live troubleshooting. F00. I may have. No, it should be okay. Yeah, okay. I haven't configured the PCs here, the IP addresses for them. So I need to go into the PC themselves and change the IP address there. So let me show you slowly. Go into the PC there, go to IP configuration and give it an IP address there. 255.255.0, and the default gateway is the router. All right, now let's try that again. We'll do that ping again. There we go. Now we're working. Excellent. So this computer can communicate with this router, but it won't be able to communicate with this just yet. We've got a bit of work to do. On this side, we need to configure the PC there as well, the IP address. And we'll do that as 192.168.2.2, I believe. I'll just double check the lab guide. Yes, yeah, 2.1. Yep, correct. So that'll be 2.2 because that's the computer, and the router, the gateway address is 192.168.2.1. All right, now let's do a ping. Ping 192.168.2.1. Great. So I got communication. The PC can ping the gateway up in the router. I'll just change that name. Router 2. And we'll go to the router and we'll ping the PC. Nice. Now I'm going to ping the other side of the router. And I already know what the IP address is. Just follow along if you're watching this, as you are watching this. And I should be able to ping from that side to that side. And it's successful. Great, and I'll do it on that side to that side. And I'm doing this to get rid of all the troubleshooting out of the way. Because if we're pinging the tunnels and it doesn't work, at least I know there's good communication. Everything can ping each other. That's not the issue. So that's why we're doing this. So configure and then verify. Always good to configure something and then verify. sorry, 10.0.02 and ping. Now, if I try to ping from that router to here, or this PC to this PC, it won't work. We haven't configured a routing table yet. We haven't done anything with the routing. That's going to come later. And by the way, I've made an error with the IP addresses. I'm going to just fix that quickly. Looking at the guide, that's actually going to be a 1.10, 10 IP address. Very important to get this right. I'm going to fix that. And this one should be a .20, 2.20. No, sorry, 2.10, 2.10. Okay, excellent, nice. All right, good. So now we got everything working, up and running. Now I'm going to set up the VPN. I'm going to set up the VPN on that router and then on that router. This is where the magic's going to happen. Because what we want to do is, let's pretend that these routers, the big internet is there. Okay? Let's pretend that right there is the internet. The internet. And we don't want anyone to be able to view our traffic. We want to encrypt it. And this is what we're going to do. So from this point to our local router, which is, just say it's like an MBN router or the router that's at your premise that connects to the internet, that's okay if it's not encrypted at this point. I mean, we don't want to build a tunnel just yet because this is a trusted network. And that's a trusted network on that side, but the internet is not trusted. We want to build the tunnel through that. And I've got the commands already there. Let's do this. I'm going to now enter these commands one by one. I'm going to go to config T. I'm going to do crypto, ISACAMP, policy 10. At the moment, in your stage of development, we don't worry about exactly what these mean just yet, but the procedure is important. So we'll create the policy first. We're going to choose the encryption algorithm. We're going to choose a hashing algorithm, but we're going to use SHA in this scenario. You should really use SHA 256 or 2512 in the real world, bare minimum. But this is a simulator. It's an old simulator. The old SHA will be okay. Definitely better than MD5 anyway. Authentication pre-share, and that means that we have the pre-share keys already there. We're not going to use any certificates or any asymmetric encryption. That's a very complicated configuration. We want to make this nice and simple so that you all can do this. Create a group, and this is the lifetime. All right, so that's that side done. We have more work to do. So now we are going to set that pre-shared key. We're going to the pre-shared key is the password. On one side, this is going to be the same password as the other side. That's pre-shared. They both know this password. Crypto, ISACAMP, key, and this is the key. This is the password. It's a very bad password, just between you and I, but it will do. And it's saying that it should be the same as that password needs to be same as the router over here. Okay, and I just need to correct that. 2, okay, and now I'm going to exit. I haven't finished yet. There's still a bit of configuration to do on router 1. I'm going to do crypto. Sorry, I need to go to configuration T. Crypto IPsec transform set. Give it a name for this. This is a bit above our pay grade in our journey of encryption, but just follow along, get this working. And we're going to map I know this might not make sense to a lot of you, but let's just go through this. The crypto map is just a mapping scheme. It's not going to work until we connect to a peer. Okay, great. I think we have a couple more settings, or just crypto map. All right, so we're in the map now. So we're just saying, we're just setting the peer. We're mapping to our peer, which is on the other side, the other router. Match address, 100, exit. Okay, good. So now we need to map that to our interface. Which is that exit there. So we need to go to interface, fast Ethernet 01, crypto, map, my map. So we created the map. Now we have to put it on the interface. Okay, so now we need to define the actual traffic. I'll copy and paste this because it's a long command. So we need to create an access list. Paste that there, and that should work. Great. So now, on the other side, we're doing pretty much exactly the same. I'm just going to copy and paste. I've got the commands already there. I'm just going to copy and paste this now to save a bit of time. Okay. Copy paste again. And by the way, this lab guide will be provided to anyone who requests it. You can follow along. Yep. That's good. And we're doing that mapping to the interface again. Paste. Excellent. We need to set up an access list again. On the other side, great. And we're missing one very important part of this, and that's creating. No, actually, should be okay. Should be fine. Now, this should work. Okay. Let's test the tunnel now. So I should be able to ping from here, even though I'm going through a simulated internet, I should be able to ping that IP address directly. Usually, when we're communicating over the internet without a tunnel, there'll be like a NAT translation, translates the inside network to the outside network, and this is in reverse, outside to inside. NAT is a NAT and port address translation, so network address translation, and PAT, port address translation, is a whole huge concept. It's how the internet works, and it's also one of the technologies that saved IP version 4. But in this case, when we set up the tunnel, we actually don't even need NAT anymore. Excuse me. We don't even need NAT anymore. We're just going to. It's basically we are connected in the same network. You know, very, 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 very similar network. Okay. Let's test this out. So show crypto. Actually, I need to exit that. So show crypto ISACamp SA. Awesome. And let's have a look at IPsec. Okay, so far, nothing's happening because I haven't sent any communication over here. So let's do a ping. If this doesn't work, we'll have to do some troubleshooting, and hopefully it will work. So now I'm going to ping from that PC all the way over to the other one, 196.2.10. and let's hope it's will reach something. If not, we'll have to do some quick troubleshooting. Um, Actually, I think I may have missed one command. I'm just going to have to double check. I'm going to do some quick troubleshooting, and I'll be back. Okay, so I spent about 10 minutes doing some troubleshooting, and it was just a really small configuration error. I've got the lab guide up and running, which will be included here with you, uh, which will be available for you. And it was just a copy and paste error. I missed out one little issue with the access list. The access list needs to be including both directions, and I've updated that on the actual um, on the documentation. So that's worked. So let's demonstrate that. So from that PC should be able to ping the other side now. So there we go. So we're getting reply. But is it encrypted? Is encryption working? If we go to the router, we can test that. And if we do a show, crypto IPsec SA. There we go. Yep, this is encrypting. This is great. Packet encapsulated 17 and 17. Yeah, we've got some encryption happening. And if we do, let's have a look at the ISACamp. Um, yeah, and it's active. Yeah, we're getting encryption here. This is working fine. So this is how the tunnel's working. So let's look at this step by step. We created the two local networks. We created one on this side and one on this side. And we can ping to those interfaces router easily. We created an interface here to connect from one router to another. So when these routers communicate with each other, no problems. But when we are sending traffic from this side to that side, through this interface, there's a tunnel. It's completely encrypted. I've got keys on both sides. So they negotiate. They know which keys to use. They know which encryption method. If we had a packet tracer in between there, a packet capture, we would see that that is fully encrypted. So I hope you enjoyed this this video presentation. Um, just remember the reasons here, that the actual typing of the commands is at this stage of your development. Don't focus on the way to configure this. The reasons, the step. It's just the theory, the step by step, and actually demonstrating this and making this work. That's the important part. But thank you for viewing, and hope to see you in another video presentation.